Hey guys, in this series we'll be covering another more complex topic, object-oriented NPCs, or non-player characters. We'll set up the basic structure for an NPC, and I'll show how to create different types of NPCs that can inherit functionality from one another to streamline the process of making a variety of different, more complex NPCs using object-oriented programming, also known as OOP. I'm going to be using one module of mine that will streamline the animation process for us. I'll also use a framework that I've been working with that I recently made free and plan to make a more in-depth tutorial video on sometime in the future, so feel free to subscribe and turn on notifications so you can check that out when it releases. Either way though, links to download the module and the framework will be in the description. Anyway, let's get right to the video. Here I have created an empty base plate and published it to Roblox as my own game. The first thing we'll do is head over to the blue framework plugin in the plugins tab, which you will have to first download from the description below and maybe restart Studio. We'll press the Set Up button, which will add a few things to our game, including a server and client script for all server and client code, respectively. We'll then head to the Avatar tab and create a new R15 avatar based on my own avatar. We'll name this avatar Base NPC and go into the Properties window, where we'll give a collection service tag called Base NPC as well. We'll use this tag in a second in order to find all NPCs of this type. We'll insert a new folder inside the server script in server script service, calling it NPCs. Now we'll head over to the blue plugin again and press the Create Module button, and then press Base Class, which should open a new window. In this new window, put Base NPC as the name and NPC as the object name, which just changes what the module's name is as well as what the variables are called inside of it. As you can see, this plugin has already set up some stuff for us for a basic OOP-Structured class. What we have currently allows for us to create a new instance of this class, as well as to define a method for destroying instances by adding chores to the janitor that are cleaned when the object's destroy function is called. I've used the janitor module in my inventory remake series, but if you're not familiar with it, it basically lets you keep track of the tasks, which are then all completed when you run janitor:clean. Additionally, you might notice that this script is requiring the janitor module in a rather peculiar way, and that has to do with my framework as well. Essentially, I've removed the need to specify a path to a module, and you can simply do _g.require with the module's name and it will find and return it. Inside the parentheses of the new function, we'll add a parameter called char, which will be the character to create the NPC object for. We'll then add a new value inside the NPC object called character, setting it to the parameter we created. This will allow us to access the character later on in the code. We'll put a simple print whenever a new NPC object is created, printing the character model that goes along with it. Up at the top, we'll define a new function using a colon called __init. The reason I started this function with 2 underscores is because it will be automatically called by my framework whenever the game starts running. If we added a function called __init to a module inside the client script, then it would run whenever the player first joins instead. At the top, we'll define a new variable called CS and set it to the collection service, which will let us check all objects with the NPC tag we set earlier. Back in the init function, we'll loop through all objects with the self.npcid tag, which I'll define in a second. For each one, we'll make sure it's a descendant of the workspace, and then we'll run the new function defined below, providing that character model as the char argument. Now we'll define self.npcid by adding it to the base NPC table as base NPC, just like we added the tag to the model itself earlier. Since init is being ran on the module table itself, then self in this case is simply base NPC. We'll also add a table to base NPC called all NPCs, which will be empty to start. Inside the new function, right before we return, we'll add the new NPC object to the all NPCs table using the character model itself as the key. Afterwards, we'll give the NPC's janitor a chore to remove the NPC object from the table. This is because when an NPC is killed and thus the destroy function will be ran once we set that up later on, we want to remove all references to the NPC object so that it can be properly garbage collected and it doesn't waste memory and cause lag for our game. If we run the game without playing, you'll see in the output that our new function has run, and it received the character model we added as well. Were we to duplicate this model a few times, you can see it runs once for each model, but only does so at the beginning of the game. Inside the replicated storage.modules folder that was added by my plugin, we'll create another folder called character, which will insert the module I mentioned earlier into, called animate. Basically what this module does is completely replaces the default Roblox animation system with my own system that works better for my own project, which also works seamlessly with NPCs as well, which is great for this case. Since we don't need to replace the default animate local script in order for our NPCs to work, you can simply comment out this character added portion like so. This is the part that creates new anime objects for each player as their characters load in, but we just want to manually create anime objects for the NPCs and our NPCs only, so we can just remove this portion. You may also notice the animation packs and animation pack default inside the anime module. It's possible to create different animation packs, switch between them from moment to moment, and even layer them on top of one another, but that would be an entirely other tutorial video to explain the process of, so for now you can just change the animations in animation pack _ default to animations of your choosing. This module should also work fine for R6, since that's what I actually originally made it for. Back in the base NPC's new function, we'll require this anime module using the _g.require like I mentioned before. Then we'll add an anime property to the NPC object, setting equal to a new anime instance. We'll also need to provide the character as an argument into this new function, as well as add an attribute to the character model called moveDirection, which will just be an empty vector3 for now. Normally, the humanoid itself has a moveDirection property, which can be used to determine whether or not the player is currently walking, but that doesn't work for NPCs, so I set up the anime module to work with humanoid.moveDirection for players and an attribute on the character by the same name for NPCs. We'll need to manually adjust this moveDirection attribute as we define movement, however, so it's not entirely automatic. After doing that, you should notice that the NPC already has the idle animation playing on it, but it's hard to test any of the others yet without a way to make the NPC walk. We'll define a couple new properties in the NPC object called current path waypoints and current destination. These will just keep track of whatever path the NPC is currently following, as well as its destination whenever the NPC moves. We will use these properties later on to calculate the distance the NPC would need to walk to reach its destination, accounting for the case of pathfinding. We'll create a property called OriginCFrame as well, which will be used mainly for allowing us to direct the NPC to walk back to its spawn location, and will also be useful when we define respawning as well. Finally, we'll create another janitor object called moveToJanitor. Because the janitor module defines a destroy method, which is simply set to run the clean method of the janitor, then we can actually add this janitor to our NPC's main janitor in order to clear up its chores whenever the NPC object itself is removed. This janitor will mainly be used to prevent conflicts and save memory if, by chance, you were to make the NPC walk to one location while it's still in the process of walking to another. Finally, although this part probably doesn't even matter, we'll loop through all the descendants in the character, checking for each one if it's a base part, and then setting its network owner to nil if it is. I originally did this because I wondered if it would fix a jittering issue I had, but I ended up doing something else later on that fixed the issue instead, and just never removed this portion. I'm pretty sure it basically doesn't change anything, but I could be wrong. Finally, we'll get to something a little bit more interesting, making the NPC walk to a location using pathfinding service. We'll define a new function called moveToLocation and specify the location as a parameter. The first thing we'll do is run the moveToJanitor's clean method to clean up anything that was done the last time this function was run. Then we'll create a variable called pathCancelled and set it to false. We'll add a function to the moveToJanitor's chores that sets this boolean variable to true, which we'll use to cancel the pathfinding in a second. We'll then define variables for the character, humanoid, and root part of our NPC model, returning if the humanoid or root part weren't found. Up at the top of the script, we'll define the pathfinding service as PFS for short. We'll also create a table called Path Configuration. This will allow us to edit how the pathfinding is calculated. Inside, we'll set agent radius to be 2, but on the screen are some other values you can change when using pathfinding service as well that may be of interest and can be found on the documentation as well. Back in the new function, we'll define npc.path as a new path using the createPath method and providing the path configuration we defined earlier as the first and only argument. We'll reuse the same path object for all pathfinding. Inside moveToLocation, we'll create a pcall, running the computeAsync function on the path object we created, using root.position as the start location and location as the end location. If the pcall does not return true for success, then we'll give a warning with the error displayed in result, and then return to stop the code. Now, we'll find the waypoints by running getWaypoints on the path object, and we'll set the current path waypoints and current destination properties from earlier to the waypoints variable and the location parameter, respectively. We'll loop through all of the waypoints and check to make sure that the path wasn't cancelled by running the moveToJanitor's clean method. If the current waypoint's action property is walk, then we'll want the NPC to use humanoid::moveTo. Before we do that, however, we'll define a variable at the top of the script called noY, which will be a simple vector3 with 1, 0, 1. Multiplying any other vector 3 by this one will essentially maintain the x and z axes while setting the y-axis to 0, allowing us to check distances from a top perspective rather than from a three-dimensional perspective, as you'll see in a second. Before we can make the humanoid move, we'll set the move direction attribute to the direction from the character's current position to the next waypoint's position, ignoring the y-axis by using the variable we just defined. Now we'll run hum::move_to to move the NPC to the waypoint's position and then wait for that move_to to finish. If the waypoint's action is jump rather than walk, we'll set the hum.jump property to true, which will make the NPC jump instead. This will allow for the NPC to jump over obstacles in theory, but can be fishy at times. At the end of this function, we'll check to make sure the path was never cancelled, and we'll set move direction back to an empty vector 3. We'll also set current path waypoints and current destination both to nil. We don't want this code running if the path was cancelled, because we're only going to cancel a move to location if we're starting another, so this code could throw it off if we run it in that case. For anything to actually happen, however, we still need to actually run this function. We'll do this near the bottom of the new function, just to test temporarily by walking to a random position. As you can see, it works great and the NPC walks to what I assume is that location. We can also make it walk to several locations one after the other, and it will wait for each one to finish before moving on. This code I've written here makes the NPC walk in somewhat of a square, though the spawn location is somewhere in the middle of that square. And look at that little guy go, I feel so proud. Removing that code so it doesn't interfere with anything else, I think I'll call that the end of this episode. In the future, we'll work on defining code for having NPCs follow parts or even moving characters, as well as defining the code for a subtype of NPC called aggressive NPC, which will attack players on sight. Said sight will include a limited field of view range and will also not detect players through walls with the help of some raycasting we'll use. But that will all come later. For now, I hope you guys enjoyed this video, and if you ever want to support my channel, or just to download the completed files for any of my tutorials, including this one, then you can become a member starting at just $2.99 a month for that and a shout out at the end of each of my videos. Thank you for watching, and have a good day.